Here's integrated 3. This is problem 11-1 CL 11-116, and it wants me to graph in 3 dimensions. So when I graph in 3 dimensions, I'm going to have a x, a y, and a z axis. So you can use your dot paper, or you don't need dot paper if you don't want it. So this one and this one, they're both going to be a point. And this is x, y, z. It's an ordered triple. And so when you're graphing in 3 dimensions, the x kind of points off to the left, and the y points off to the right, and the z points straight up. So all you have to do is make 3 little tick marks on the x for the 3. And then on the y, make 4. I try to make them look like they're spaced the same, and then you can kind of show you can kind of just like show that, like if that was graph paper, and then you're going to go up by 2. And so the way you do that to show it is you can show 2 on your z-axis, and then what I do is I'll just make, if I draw it all the way up into the sky like this, it's going to look way longer than 2. So you just kind of go like this, put a point, and then you can kind of like put some tick marks so that it's supposed to look kind of like it's sticking up out of the paper. So no, it's not perfect, but that's how I do it. If I would have used some dot paper, it might have looked a little nicer. So then this one, this is x, y, and z. And actually on that one that I just did, let's see how it looks the way that your answer book. So see, your answer book doesn't look a whole lot different than what I did. They just used some dot paper. So it's fine. And then on letter B, I have to go, if this is the positive 1, positive 2, positive 3, or whatever, I need to go to negative 2. So that's going to be over here. I know, surprising. And then y is going to be 3. And so this is, z is going to be 0. So it's just going to be flat. It's just sitting flat on this plane. It's right there. And so if you look in your answer book looks a little bit like how I did, like that. Okay. And then I kind of think it's a little nicer to not have to use the dot paper. And then this one is a plane. This is going to be a plane. So the way you do this is you get the intercepts. Like I want to know where it crosses on the x-axis and the y-axis and the z-axis. So what I do is I just plug in, like let's say I'm looking for the x-intercept. I'm going to plug in 0 for y and z. So I can just cover those up. 2x, because if that's 0, it's going to be 2x plus 0 plus minus 0 equals 6. 2 times what equals 6? X is 3. So I'm just going to go 1, 2, 3. That's an intercept. Okay, this thing's going to be a plane. Okay, the y-intercept happens when x and z are 0. So I can just cover them up, and I get y equals, if I just cover those up, I get y equals 6. Y equals 6. So I got to go 1, 2, 4, 6. And then z, if x and y are 0, negative z is 6. So z must be, negative 6. So I'm going down there, and it's going to be negative 6. And then I'll even be fancy because I have different colors on this pen. And it's supposed to kind of look, it doesn't look very much like it at all, but it's supposed to look kind of like a sheet of glass, like a It's supposed to look like a plane. And so you can see that it looks very much the same as the picture in the book. And that's all I got.